This lecture is going to go over the conversion between moles, mass, and molecules. Things you will want to have with you: a calculator, periodic table, and objective sheet. Now, a lot of this is going to rely on you being able to find the molar mass. So if you are not comfortable with that, we need to make sure that we get that under control before we move on to this, because I'm not going to go into really doing the molar mass of each of these things. It's assumed that you know how to do that. All right, so what is a mole? Now, briefly talked about this already, that a mole is a quantity. Much like a dozen is a quantity. If I asked you for a dozen eggs, you would bring me 12 eggs. Now, 1 mole is 6.02 times 10 to the 23rd, so a huge number. It's not like 12. Now, don't let this big number intimidate you. You've used numbers like this already. Remember using Planck's constant, using the speed of light. You're familiar with this. It's okay. So if I asked you for a mole of eggs, you would bring me 6.02 times 10 to the 23rd eggs. But you can have a mole of anything. You can have a mole of paper clips. You can have a mole of pillows. You can have a mole of chemistry binders. So it's just a quantity. Now, when we're specifically going to be talking about it in terms of elements and compounds and molecules, but don't be intimidated by the size of that number. Now, this scientist named Avogadro, was the first scientist to discover that 1 mole of a substance equaled 6.02 times 10 to the 23rd particles. Now, with this word particles, you also will see it be called molecules. Okay? So either way, we're talking about molecules or particles. So instead of having 6.02 times 10 to the 23rd paper clips, we have 6.02 times 10 to the 23rd particles. So there's what I was just saying. Particles could mean molecules, or it could mean atoms. Now, you've seen this already when you did your molar mass, that writing MOL is the same thing as a mole. Now we're adding this term molecules. So I want you to be very, very careful, because it does not mean molecule. Both of them start with MOL. So it's very easy for us to just confuse them if we're working too quickly and not paying attention to details. So please remember that MOL equals mole. MOL does not mean molecules. All right, so just a review really quick of finding your molar mass, which we could also call our formula mass. The grams of a substance per 1 mole. So for H2O, we have 1.01 is our molar mass of a hydrogen. We have 2 of them, gives us 2.02. Oxygen, 16, we have 1. So we have 18.02 grams per mole. Just a quick refresher. All right. This is something that helped me tremendously when I was in high school chemistry, was a molehill. So you may or may not be familiar with the mole, the little animal that lives in the ground and digs holes in people's yards. They make these little things called molehills out of dirt. So this is our molehill. Now, for us to go, this is going to help you when you're converting from one unit to the other, because that's really what we're doing. So we could go from grams to moles, and that's a direct relationship. We could go from moles to particles. And if I wanted to go from grams to particles, I cannot just go directly from grams to particles. This will make a little bit more sense in just a second. But to go from grams to particles, I have to go from grams to moles, and then moles to particles. So that's where it helps me just kind of visualize what path do I have to take. Now, when we're talking grams, you're going to associate that with the molar mass. And when we're talking particles, you're going to associate that with that 6.02 times 10 to the 23rd number. I'm not going to give you this on a quiz, so make sure that you are familiar with this on your own if it does help you. If it doesn't, that's fine too. Alright, so some equivalent statements. They're coming back from all that dimensional analysis we've done before. 1 mole equals your molar mass. So, like 1 mole of water equals 18.02 grams per mole. That's what that means. 1 mole also equals 6.02 times 10 to the 23rd particles. So that's just an equivalent statement from moles to your grams and from your moles to your particles. So if I have 18.02 grams per mole of water, that's my molar mass. That equals 1 mole, and that which equals 6.02 times 10 to the 23rd particles of water. But what happens when we have more than 1 mole? That's what we're doing now, okay? We might have more than 1 mole. We might have less than 1 mole. So we are going to have to use these equivalent statements to find those conversion factors. Now is when you really want to make sure you've got that calculator and that periodic table out. Alright, so here's a type of problem that you might see. How many grams are in 1.72 moles of calcium carbonate? Alright, so first thing you got to do is remember what calcium carbonate is, because I'm not giving it to you anymore because you've got through Unit 4. So, calcium carbonate, if you remember, CaCO3. So, step 1 is what is my molar mass? So, I'm going to give you just a minute. I'm going to pause the video here, find the molar mass, come back. Alright, molar mass, you should have got 100.09 grams per mole of calcium carbonate. So in 1 mole of calcium carbonate, I have 100.09 grams. But I don't have 1 mole. I have 1.72 moles. And I want to know how many grams that is. So what am I going to do? How am I going to find that? I'm going to use equivalent statements. It's easiest if you start with the unit that only has, or the number that only has 1 unit. So your 1.72 moles of calcium carbonate. Now, make sure that you are writing out what the unit or what the compound is. It's going to tremendously help you in the future. Now, this is the only other value that I have. I have moles right here to get moles to cancel because I want to be left with grams. Moles needs to be on the bottom, all right? So it's going to be 100.09 grams per 1 mole of CaCO3. Now, if you needed this to be flipped and you needed grams to be on the bottom, it's just fine to write it at like this: 1 mole, 100.09 grams. That's the same thing. You work it just like you do with dimensional analysis. Just flip your values so you can get the units to cancel that you need to get to cancel. All right, so what do we have to do here? We just multiply straight across, because looking at my units, moles of CaCO3 and moles of CaCO3 are going to cancel. So 1.72 times 100.09 gives me a number 172.1548 grams, because that's the unit I'm left with. Can we stop there? We would think so. But we're going to pull one more thing in. We're going to pull in those sig figs. Okay? So, got to remember that as well. So, looking back up here, sig figs in this, I have 1, 2, 3. And then in my molar mass, I have 1, 2, 3, 4, 5. Go by the least, so my answer should have 3 sig figs. Nothing rounds up there. I'm going to be left with 172 grams. Okay, so this is when you're going to start to really pull in all of those things you've done before, and they're really going to be applied to what we are doing now. All right, so how many molecules are in the sample? What sample? The sample that we just did. So flip back real quick. I'm just going to take some pieces of information that we have and we're going to carry them over. We had 1.72 moles. And our molar mass was 100.09 grams per mole. And we're looking at CaCO3. How many molecules are in the sample? Now, how do I get to molecules or particles? How do I get there? That goes back to my little molehill. Remember this that we just looked at? This was grams, this was moles, and this was particles. So the easiest way for me to get to the particles I'm looking to get here is from where? From grams, remember I have to go here and then jump, but from moles I just have to go straight from moles to particles. Okay, so it's much easier for me to go from moles to particles than go from grams to moles and then to particles. So we know we have 1.72 moles. Remember, molecules and particles are the same thing. So I'm going to start with the 1.72 moles. Of CaCO3. And now remember, with this value here, we associate that 6.02 times 10 to the 23rd number. So in 1 mole of CaCO3, I have 6.02 times 10 to the 23rd particles. Now check your units here. 1 mole cancels. I'm left with particles. That's what I want. So go ahead and do the math. Remember to use your E button, not a caret. And you get 1.035 times 10 to the 24th. Go back to our sig figs. One, two, three. 1, 2, 3. Answer should have 3. So we're left with 1.04. Just rounded this 5 up. Oop. Rounded the 5 up to give me 1.04 times 10 to the 24th molecules. Alright, how many moles of sulfuric acid are in 452.16 grams? So, before we were given the moles and we had to find the grams. Now we're being given the grams and we want to find the moles. So step 1 of that, determine what your compound name is. So remember, sulfuric acid is H2SO4. Finding your molar mass of that, I'll give you just a second. Pause the video. Find your molar mass. Alright, molar mass, you should get 98.09 grams per mole for your H2SO4. Now, we're looking for moles. We know how many grams we have. So remember what I said earlier, you want to start with the value that you only have 1 unit in. This has 2 units, grams and moles. This just has grams. Okay, so we're going to start with the one we have 1 in. We have 452.16 grams. We're going to use our equivalence statement. We want grams to cancel. For grams to cancel, does it need to be on the top? Does it need to be on the bottom? Bottom. 98.09 grams is the same as 1 mole. You know what I did not do here? Put my compound. Alright, check your units, make sure they cancel. Grams of H2SO4, grams of H2SO4. Let's go ahead and do this. We're going to divide here. You get 4.6096 moles. But what do I got to do? You got it, sig figs. 1, 2, 3, 4, 5. 1, 2, 3, 4. Go with the least. 1, 2, 3, 4. This 9's going to round this up to a 1, which would give me 4.61, but that's only 3. What number can I add? 0. Okay. This next part I'm going to let you do on your own for the next problem. It's going to come off of this problem here. So you are going to determine how many molecules are in the sample. So I'm going to go ahead and get you started here. Remember let's do write some information down. We had 452.16 grams. We had 4.610 moles, and our molar mass was 98.09 grams per mole, and remember our sample is H2SO4. Pause this, come back, and we'll take a look at your answer. Alright, so here's kind of your setup. We're going to start with what we have 1 unit of. Remember, it's easiest to go from moles to molecules instead of starting with grams and grams going to moles and then moles going to molecules. Just make it a 1-step problem instead of a 2. So we have 4.610 moles of H2SO4. We found that out in the last problem. And we're going to multiply that by 6.02 times 10 to the 23rd molecules per 1 mole. Your moles cancel out, and you are left with 2.78 times 10 to the 24th molecules. If you are not getting this answer, especially if your exponent is wrong here, make sure that you type that in with the E and not with the times 10 caret 23. All right, that is all. Go ahead, work on some practice problems. As always, let me know if you need any assistance, and good luck.